Let's talk about those mathematical formulas, those encryption algorithms. A cipher is just another word for an algorithm. And there are two types. There's the block cipher and the stream cipher. In block cipher, we take a big chunk of data and we break it up into blocks and we encrypt each block, a block at a time. In a stream cipher, we encrypt the data as it flows. So like for example right here, see this hard drive right here? We would do block ciphers on files stored on hard drives. So we have a fixed file that's stored on storage media, and in encryption, chunk at a time, it would be encrypted. That's a block cipher. But if we're transmitting across the network, if we're transmitting in the air, on a phone call, something transmitting in real time, we would use a stream cipher, because you can't like take a block of packets, encrypt them, and let them go. You have to encrypt them as they go by. So that would be a stream cipher. The long time used granddaddy of block ciphers was something called DES, the Data Encryption Standard. And it would break up the data into 64-bit blocks, and it would encrypt them or encipher them. And it would decrypt them or decipher them. And it used a 56-bit key. So the idea is that we are taking equal size blocks, fixed length blocks, and transforming them into something of equal length. Now, DES is inherently weak compared to today's technology. So what they did was they would actually do it 3 times in a row, and they called that triple DES. And instead of being it was still 64-bit blocks, but the key length was actually 128 bits. DES was replaced by the Advanced Encryption Standard, AES. The National Institute of Standards, NIST, decided that they needed to upgrade DES, so they had a contest. And they said, all of you people who create algorithms, just supply yours, and in this contest we'll see who wins. And it was these two people, and they had an algorithm that was named after their two names together, called Reindahl. And it became the Advanced Encryption Standard. It is now the Symmetric-Key block encryption standard. It's the block encryption algorithm for securing unclassified but sensitive U.S. government documents. So it's considered suitable for everyday use, unclassified but sensitive. So what we do is we do the block cipher, and we keep on iterating or keep on repeating the operation. Now, AES can have different block sizes. So we can have 128-bit keys. So we can have 192-bit keys and 256-bit keys. So if you see AES 128, 192, 256, you know what they're talking about. Whereas DES was 56-bit key, although they added something for CRC. Now, there are some signature schemes. There's the DSA, Digital Signature Algorithm. It's specified by FIPS. It's 186-2, and it is used to generate and verify digital signatures for unclassified sensitive applications. And then there's also just digital signature. This is a computer-generated signature. It's a specific set of parameters and rules that allow the signatory's identity and data integrity to be verified. Now, to say this in plain English, what's a digital signature? We know that when you have two keys, public and private, I give you my public key, you encrypt the data, you hand it back to me, I decrypt it with my private key. Okay, is there a way to go the other way with the private key? Yes, it's called a digital signature. What that means is, if I want to send you something that you can prove only came from me, I will use my private key to digitally sign something, basically create a hash. And it uses a hashing algorithm, and my private key is included in that thing that we're hashing. You run the hashing algorithm, and you use my public key to prove that it came from me. I'm the only one who could have used my private key. You can prove it came from me by using my public key. Now, of course, if someone steals my private key, they can do all sorts of things in my name. So the idea of a digital signature is that I'm the only possessor of the private key. I sign this, whatever it is, with my signature, with my private key. You prove it with my public key, and you know it came from me. That's the idea of a digital signature. And the DSA, the digital signature algorithm, is the one specified by the US government to generate and verify signatures for unclassified sensitive applications. Now let's talk about RSA. It was actually 3 guys at MIT, Ron Rivest, Adi Shamir, and Leonard Edelman. They learned about the idea of the 2 keys actually from some colleagues of theirs, Whit Diffie and Martin Hellman, who created the idea of 2 keys. And they took that concept and ran with it and turned it into a company with a product. So RSA is an algorithm that uses 2 keys, and we use it on the internet for encryption and authentication. It is the most commonly used 2-key algorithm that we have. It is the de facto encryption standard. It's not specified by government, it's just that everyone adopted it. The way it works is it does computations using large prime numbers. And a prime number is basically a number that can only be divided by 1 or itself, meaning no repeat patterns, meaning it's hard to break because it's hard to figure out any repeats in it. So it uses large prime numbers, factors, as its basis. A message digest, this is a hashing algorithm. It will produce a string of a fixed size. So we use hashing functions to calculate the message digest of any sized information, whether it's 1 letter or whole volumes, whole books. If any bit of the input is altered, there is a 50% chance of each output bit changing. And it's more than 50%. You will see huge changes. The thing is that it is very difficult to take 2 different inputs and have them produce the same message digest value. Now, message digest has long been the hashing algorithm, and there were variations of message digest. So we've had message digest MD2, MD4, MD5, and in fact that MD2 was the algorithm for LAN Manager, the authentication protocol for Microsoft, MD4 for NTLM, MD5, NTLM version 2. MD5 was long the hashing algorithm standard. It's been replaced by the secure hash algorithm. So secure hash algorithm, SHA, this is again a hashing algorithm. It's cryptographically secure. It will produce not a 128-bit message digest like this one does. This one is typically 128. This one's 160-bit, and it can go up to 264 bits. So SHA-1, 160-bit message digest. SHA-2 does 2 hash functions with 2 different block sizes. You can either have a SHA-256 or SHA-512. And the word length, meaning the length of things that you work on, can either be 32 or 64 bits long. There is also a SHA-3 that does an exclusive OR function and then permutates the result. SHA-3 is not in common use just yet, but realize that the secure hash algorithm, SHA, is the one that everyone is using now, not MD5 or the MDs anymore, although the MDs are still in use for backward compatibility. Now, secure shell, this is a replacement for the old clear text telnet and the old clear text remote utilities like remote logon, and remote copy. And everything in Secure Shell is done with two-key encryption. So when you create a Secure Shell session, you create an encrypted channel for remote logging in and file transfers and command execution. It's very strong host-to-host authentication and gives secure communication over the internet. The thing about Secure Shell is you need a Secure Shell client, which, by the way, does not exist by default in Windows. It does exist in Linux, it does exist in Cisco, it does exist in other operating systems, not Windows. So you download something like PuTTY, which is a free Secure Shell client. When you negotiate a session, an SSH session, your client will generate its own private public key pair. The server has already been set up with a key pair. You will trade public keys, and with that, you now have each other's public key. In order to save sort of performance, the two sides agree upon a temporary session key that's destroyed when we're done. The session key is the one that does the actual encryption. It is actually symmetric, but it is protected by the asymmetric keys on the two sides. Secure Shell is usually used so that I can have a remote administrative session from my client to this server or this router or this switch. But it also has the ability to do secure file transfers as well, and secure copies as well. So it's not just sending remote commands. So that's a little background in algorithms and their use.